All right. Couple people still checking into on campus. That's fine. Please make sure you do that in the next couple of minutes. Um, Today, we're gonna do a couple things. All right. I want to try and break this down even maybe a little bit simpler than I did last class. Okay. So first of all, keep in mind that these lectures you can go back and watch after we're done with the actual class. Okay. So if you do have questions and for whatever reason I can't answer right off the bat, you can go back and watch this. Uh, and I feel like last class, especially, we went over several different types of problems, all which corresponded pretty directly with the IXL. Okay. But today, um, I want to simplify it probably maybe even a little bit further. Um, I took a couple of questions from the attendance. I'll address some of those. And then I want to just start working on 11 to 19 on the worksheet. Because that'll kind of lead into your homework tonight. A couple things before we do that. Um, some things on homework. If you just didn't do the homework when I told you to, that is a pretty major problem, especially now. It's this whole thing doesn't work unless you are actually doing the work. It doesn't work in a regular class, but especially doesn't work now because I need to know your questions so I know exactly what to address day to day. All right. So homework is like a priority here. All right. Um, so the questions that I'm seeing from attendance are mainly uh, they mainly circle around simplifying radicals and working with them in the Pythagorean theorem. So I'm not gonna. Yeah, the homework was the IXL. I can load our. Alex, try and reset your computer. Okay. Where was I? So I'm not gonna specifically and only deal with radicals today because I want us to know it in the context of trig. Okay, so we're still going to be practicing trig, but there's going to be some problems where radicals are involved, and hopefully that'll kind of clear things up. Okay, so uh, we're going to start just with number 11 and continue on to that. And as we have questions, ask them. Okay. Also, one like minor change, and it shouldn't affect anyone ever. Um, your points, so checking in, that's going to be worth 2 points. All right. If for whatever reason you are distracting in the chat to me, or distracting on Teams after, I'm going to take away those points. All right. So even if you attended, even if you checked in, if you're distracting to everyone or me, then that's kind of a problem. And we ran into that last class, which that's not going to continue. All right. So with that out of the way, we're going to start on number 11. All right. So if you haven't written this down in a notebook and actually tried it, I want you to try it first. Okay. So I'm going to give people like maybe a minute just to kind of set things up. Remember, the first thing that we should always do is just define what terms we have. Okay. So as you're writing this down, step one, define what sides you have. So take a second, go in your notebook, define what sides you have, and if you can work a little bit ahead of that, go ahead and work a little bit ahead of that, um, and then we'll get going. All right. So take a minute and try this on your own. So the sides that we have are all dependent on where our angle is. In this case, we're dealing with theta. All right. So if we draw a line from theta to the other side of the triangle, we get our opposite side. Then we can find our hypotenuse, which doesn't really have to deal with theta, but it does have to deal with our right angle. Okay, so if we draw a line from our right angle to the opposite side of the triangle, we get our hypotenuse. And then the leg attached to theta, that's not the hypotenuse, that's the adjacent side. Okay, so we define what sides we have. Second, define what side you need. And write an equation in order to get that. How do we know which one is the hypotenuse? All right, so if you, every one of these triangles we're dealing with, we're always dealing with the right triangle, right? We want to locate the right angle, which is always the one with the little box on it. And then from that right angle, we just draw to the opposite side of the triangle, all right? And then this is our hypotenuse. It is also just always the biggest side. So if they're two, like, if you have all three sides that are labeled, and you have two really small sides and then a lot bigger one, that bigger one is always the hypotenuse. Okay. Now, step 2, define what side you need and write an equation. All right. So then we go to the actual question, which is to find the cosine of theta. All right. And cosine back to the first day we started this, is going to be the opposite, or sorry, the adjacent over the hypotenuse. And we have the hypotenuse and the opposite, but not the adjacent. So we need the adjacent side. Okay, so we defined what side we need, and now we need to write an equation in order to get it. Okay, so for all right triangles, they all follow the Pythagorean theorem. And that is the adjacent squared plus the opposite squared is equal to the hypotenuse squared. And that is true for every right triangle all the time. Okay, and then we just place those numbers in. Okay, so the adjacent, we don't actually know that, so we're going to keep that the same. The opposite side is 3. And the hypotenuse side is 3 rad 2. So we do that for every triangle. So if this was asking for the sine of theta, we already have the opposite and the hypotenuse. So you wouldn't actually have to do this. You really only have to do this when you have two sides, but the one side that you need is not one of those two sides. So for example, like we need the adjacent side for this one. We have the opposite and hypotenuse, so we need to find the adjacent. Okay, but if this was sine, we wouldn't actually have to do that. So we'd find what side we needed. We needed the adjacent side. Okay. Then we set an up equation for it, which is this right here. Next step is to just solve for that missing side. If we actually need to solve. So again, if this was sine, which is opposite over hypotenuse, we wouldn't need to solve for the third side because we don't need the third side. We already have the two sides we need. In this case, we don't have the two sides we need. Okay, so then we just simplify. So we still don't know what the adjacent is. Three squared is 9. And then 3 rad 2 squared. We can actually rewrite as 3 rad 2 times 3 rad 2. And I think this is where people start to get a little bit mixed up. Okay, so when you have 3 rad 2 squared, that square tells you how many times we're multiplying what's inside the parentheses by itself. Okay, so 3 rad 2 squared, again, is 3 rad 2 times 3 rad 2. Okay, and in order to simplify that, in order to multiply those two things together, we have to multiply the numbers on the outside of the square root, so the 3's. Okay, so 3 times 3 is 9. And then we have to multiply rad 2 by rad 2. Okay, so rad 2 times rad 2 is really rad 4. Which is, the square root of 4 is just 2. Okay, so then this entire thing becomes 9 times 2. Conrad, I'm not sure exactly your question. Okay, so how do you know which number would be with x? Right now, there are no x's in this question. Okay, so hold on to that for just a minute. And if you need me to, I can help you out on Teams in a little bit. Okay, but let's focus on this just for a second. Okay, and then we can simplify a little bit further. 9 times 2 is 18. All right. So now we have the adjacent squared plus 9 is equal to 18. Okay, and we're trying to solve for that adjacent squared. We're trying to get adjacent by itself. We're trying to get blue by itself. Okay, so then in order to get that by itself, we have to subtract 9 from both sides. So when we subtract 9 from both sides, we're left with the adjacent squared on the left-hand side, and then 18 minus 9 is just 9. Okay, but we're not solving for just the adjacent squared. We're solving for adjacent. Okay, so we don't want the number squared, we just want the number. Okay. So in order to get that just number, we have to undo that 2. We have to undo the square. And in order to undo a square, you have to take the square root. So if we take the square root of both sides, right, because what we do to one side we have to do to the other, that undoes that square, so we're just left with the adjacent. And then the square root of 9, that's just 3. And then we solved for our missing side. Okay, before I go on, are there questions about how I got there? So that little 2, that circled little 2, that's squared, right? So this, that in that little box, that's the adjacent squared. And in order to undo the square, we take the square root of both sides. When we take the square root of something squared, it just leaves what's inside parentheses. Okay, so the square root of the adjacent squared is just the adjacent. So that 2 cancels out. So yes, you kind of just get rid of that little 2. Okay, so we solve for the missing side. That next step then is to substitute in for our actual equation. Okay, and what I mean by that is we need to use this adjacent side and this hypotenuse in our cosine equation. Okay, so cosine of theta then is really adjacent over hypotenuse, which is 3 over 3 rad 2. Now, this is almost correct. And again, I think this is where people start to get a little bit confused. This is not a rational answer. Okay, it's not a rational answer because there's a square root in the denominator. In order to get the square root out of the denominator, we have to multiply by some clever form of 1. And I guess this would be step 5. So step 5 would be to rationalize, okay? And in order to rationalize that 3 over 3 square root of 2, we have to multiply by some clever form of 1. Okay, and some people were asking, like, when do I actually do this, or when do I simplify and when do I not? This part, it really doesn't matter. you just have to get the square root out of the denominator. If you can do that, then your answer is 90% correct. Okay, so in this case, we want to get square root of 2 out of the denominator. And we should know that whenever a square root of 2 times a square root of 2, whenever those two things are multiplied together, we just get 2. So then in the numerator, 3 times rad 2, that's just 3 rad 2. And then 3 rad 2 times rad 2 is 3 rad 4. Rad 4 is just 2. So then we have 3 rad 2 over 6. And then now this is rational, and then we can just simplify. So then we just simplify the whole numbers, right? So 3 over 6 simplifies to 1 over 2, and then the rad 2 stays up there. So we can really write this as square root of 2 over 2. And then this, square root of 2 over 2 ends up being our answer. Okay. I get that this looks like a lot, and that's why we're practicing it, because really there's no like shortcuts here. It's really about getting to understand these radicals, and as soon as you are used to dealing with these radicals, it gets a whole lot easier. I get that the actual like ratios, the SOHCAHTOA stuff, that's easy. Pythagorean theorem is a little bit harder, but then mixing those two things together and rationalizing, that's when it gets to be a little bit tricky. Okay, so before we move on to the next one, are there any questions over how we got anything on this screen? Okay, it's good that you're understanding a little bit better. Keep in mind though, this is you guys kind of watching me do this. All right, where this gets tricky and a little bit frustrating is when you go off kind of on your own and do this without a whole lot of help. Okay, so it's okay if we're struggling with this right now. It's not like I'm testing you on this right now. And I get in this context even probably a little bit more difficult. But it's okay to struggle with this a little bit. This is difficult. This is different. But that's why we're gonna continually practice in this. All right. So let's move on to the next one. And that's number 13 on that worksheet. And actually, this one should be fairly simple. And as I'm kind of setting this up, go ahead and try first, I guess, define what sides you have and what sides you need. And I'll give you like 30 or so seconds to just kind of look at this and see what you need, see what you can do without really doing any real math. Okay. Okay. So on number 13, we're given this diagram. Theta, we have one side that's equal to 7 and one side that's equal to 24. All right, and remember, step 1 is to define what sides you have. Okay, so, and I forgot, this is the square side. All right, if we drew a line from theta, it's the opposite side of the triangle. We get our opposite side. If we draw a line from our right angle, it's the opposite side of the triangle. We get our hypotenuse. And actually, this is a little bit more difficult than I thought, because we're not given our hypotenuse, but we do have our opposite, our hypotenuse, and that makes this the adjacent. Okay, so that's step 1, just defining what sides we have. Step 2, define what side you need and write an equation. Okay, so from SOHCAHTOA, we want sine, which is opposite over hypotenuse. So we want the opposite side, and we want the hypotenuse. We don't have the hypotenuse, so we need to find it. Okay, so if we set up our equation, our Pythagorean theorem says the adjacent side squared plus the opposite side squared is equal to the hypotenuse squared. Then if we substitute our values in, we get 24 squared plus 7 squared. And then we still don't know the hypotenuse. $24 squared, if you plug that into a calculator, that's 576. 7 squared is 49. And then we still don't know the hypotenuse squared. Okay, but then we can simplify this left-hand side and then just solve for that hypotenuse. So 576 plus 49 is 625. Then we have that the hypotenuse squared is equal to 625. Okay, now in order to get just the hypotenuse by itself, in order to get rid of this squared, we have to take the square root of both sides. So then we have that the hypotenuse is equal to the square root of 625. Now here's where it gets a little bit difficult for a lot of people. All right. We have to simplify that square root of 625. And if you didn't have a calculator, we would want to make a factor tree. Okay. So we would take 625. Let's scroll down just a little bit. So this is where it comes in handy knowing some quick kind of factoring tricks. All right. So if you ever have a number that ends in 25, you know that 25 is going to go into it. Okay. If you ever have a number that ends in 5 or 0, you know that 5 is going to go into it. If you have an even number, 2 goes into it. And there's a lot of like little tricks that you just kind of learn on the way, right? Now I know because that this ends in 25, 25 is a factor of 625. So I'm going to start there because I know that 25 is a perfect square, and that'd be something that we can really easily use right off the bat. So if we divide 625 by 25, we get 25 again. So 625 can be rewritten as the square root of 25 times the square root of 25. And I can do this right now because 25 is a perfect square. If neither of these two factors were perfect squares, we couldn't do this. Okay. Now, after that, we can simplify both of them. So square root of 25, that's just 5. And then again. And then 5 times 5 is 25. So our hypotenuse side is just 25. So we solve for the missing side. Now we need to substitute. And before I do that, are there questions about what I just did? All right, so now that we have both of the sides, so we define what side we need and write an equation for it, we solve for the missing side. Now we need to substitute. So the opposite side, that's 7. The hypotenuse side, that's 25. And that is a rational fraction, and that is simplified. So then this is our answer. Okay, and I want to kind of go back just a little bit, back down to here, right? As you do these, as you work more and more with radicals and perfect squares, knowing the perfect squares is very, very helpful. So like 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, right? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. And as you go up and up and up, it gets probably less likely that you're going to need them. But the more you know that, the better. So 625, I knew right off the bat that that's 25 times 25. And you can always plug that into a calculator, take the square root of 625, and just see if it comes out to a whole number that isn't a decimal, right? So before I move on to maybe one or two more examples, are there any questions over this? Okay. So your homework, and I'm going to keep going over one or two more examples, but I do want you to know your homework is numbers 10 through 20 evens. So 10, 12, 14, 16, 18, and 20 on this worksheet. All right. So this worksheet is in topics, it's trig practice, and then in parentheses harder. And it'll also show up in your assignments tab. Okay. So 10 to 20 even. Uh, and I want you to submit that by submitting it to On Campus. And you can do that in one of two ways. You can either download the file as a PDF and then write notes in it with your tablet, save that, and then submit that to On Campus. So you can do it that way, or you can just handwrite them in a notebook, take a picture of them, and then submit it as a JPEG. Okay. If you submit it via pictures, don't submit it in a Word document. So some people could copy and paste those pictures and then put it into a Word doc. That doesn't work quite as well as just a JPEG. Okay. I do have a couple of download spaces available. If for whatever reason you need more of that, then just let me know. But I think 3 should be about enough. Okay, so homework 10 to 20 even, submit it to On Campus. Okay. All right. So we'll do one or two more. Okay. So in this equation, or in this problem, we're trying to find the sine of theta. And again, the first thing we should do is just identify what sides we actually have. Okay. So if we start, and sorry, we're not trying to find the sine of theta, we're trying to find the sine of x. Which is a little bit different, but it's the same idea. So we're dealing with this vertex right here, which means we're dealing with this angle right here. All right. So if we draw a line from that angle to the opposite side of the triangle, we get our opposite side. And then we can get the hypotenuse by drawing a line from our right angle to the opposite side of the triangle. And then the adjacent side is the one that's left over. So we define what sides we have. Now we need to define what side we need and then write an equation for it if we need to. Okay, so sine is going to be opposite over hypotenuse. And then, since we have both of those, we can skip to solve for the missing side and just go straight to substitute. So our opposite side is 5. Our hypotenuse is 13. And that is simplified. And then we're done. Are there questions over this problem? How is it done already? Well, since this is asking for the sine of x, that means it's opposite over hypotenuse. And it gives us the opposite and the hypotenuse sides. So we don't need to solve for a missing side. We're already given everything we have, or everything we need. And then it's not irrational. It's a rational fraction. So we don't need to rationalize it. And there's no square roots involved. So we don't need to simplify anything. And then on top of that, 5 over 13 is as simple as I can get. Okay, I want to do one more, and I'm going to take this directly from my Excel. All right. So this is directly from my Excel. This is in the 90s. So these are among the harder ones that you can get. Uh, so given this diagram, we want to find the tangent of k. So because we're dealing with k, we're dealing with this vertex right here, which means we're dealing with this angle. All right, so step one is to just define what sides we have. All right, so if we draw a line from k to the opposite side of the triangle, we get our opposite side. If we draw a line from our right angle to the opposite side of the triangle, we get our hypotenuse. And then the only side left, that's our adjacent side. So we defined what sides we have. We need, so tangent is going to be opposite over adjacent. And we have both of those sides, so we don't need to solve for any side here. So we don't need to write an equation. We don't need to solve for the missing side. We really just need to substitute. So when we do that, we get root 57 over root 11. And again, I think this is where people kind of start to get confused. All right. So I think one of the questions in that attendance question was, do I simplify first or do I rationalize first? And you can do either one. I usually like to, well, it's kind of up to you. I would rationalize this first. Okay. So everything up until this point was super, super easy. Substitution, we didn't need to solve for any missing sides. Now we just need to rationalize. So in order to rationalize, we can't have a square root in the denominator. So we have to multiply by that square root in the numerator and the denominator. So we'd multiply by root 11 over root 11. And when we do that, (57 times 11), that's 627. And then in the denominator, square root of 11 times square root of 11, that just ends up being 11. And then when you plug in the square root of 627 in a calculator, you get something like 25.0399. So it's not a perfect square. We know that. Now this is a rational fraction. But let's see if we can simplify it. All right. And I'm going to run you through a couple of scenarios that you should at least be familiar with. All right. So when we're simplifying 627, we need to find factors of 627. Why don't you multiply the 11s? We did. Square root of 11 times square root of 11. Okay, so we could rewrite that as square root of 121, which ends up just being 11. All right. A quick shortcut you can do with that is if you ever have a square root times itself, it just ends up being the thing inside the square root. So like square root of 7 times square root of 7. You could rewrite that as the square root of 49, or you can just simplify it as just 7, okay, which is the square root of 49. The square root of 9 times the square root of 9, that just ends up being 9. All right. Square root of 101 times the square root of 101, that's just 101. So I just took a little shortcut. But when we are factoring 627, we know that this number is odd, right, by the last digit. So that means 2 is out of the question. Okay. if it is divisible by 3, and this is kind of a trick that if you don't know, you should, just because it's useful. If you add up 6 plus 2 plus 7, you get 15. Because this is divisible by 3, this entire thing is divisible by 3. Okay, so 3 is a factor of 627. Okay, so if you add up all the digits and that total is divisible by 3, then the entire thing is divisible by 3. Okay, so if we divide 627 divided by 3, we get 209. And that doesn't really leave us anywhere. In fact, this, since there are no other factors, right, we could then factor 209, but that just factors into primes, which doesn't get us anywhere. And I know that this part is a little bit confusing, but if we can get here and at least try to simplify that, that would be our answer. Okay. Again, this takes practice. Sometimes I trip up on this. It's okay to struggle with this just a little bit. As you do this more and more and more, you get better at it. Okay, so I'm gonna stop there. If you have any questions, I'm gonna leave this open for the next like 30 seconds or so, 30 seconds to a minute. Keep in mind your homework is 10 to 20 evens on that worksheet. Please submit that to On Campus. Okay, no. 627, we can factor that as root 3 times root 209. But neither of these simplify under square root. Okay, so we could simplify that 209, but it doesn't go anywhere. Right, it's square root of 627 over 11, but we can't simplify 627. We kind of can, like this, but we would rather just have a whole number under the square root. Okay, so it ends up just being 627, square root of 627 divided by 11. Because there's no perfect squares that we can take out of 627. Okay, so it just stays like that. If there are no perfect squares that you can factor out, then it just stays as is. Okay, so like I was saying, homework 10 to 20 even. Submit that to On Campus. You can either download the PDF, do it on the PDF, save it, and then submit that, or you can do it in a notebook, take pictures of it, and then submit that. Okay. I'll leave this open for the next 10 to 15 seconds, and then I will be in Teams. Okay. So if you have further questions, really general ones, you can put it up here. If not, I'll be over to Teams, and then I can help you there. Okay. Okay, so if you have any further questions, I will be on Teams. Otherwise, please do the homework, and that is it for this lecture.